the blower door to pressurize the house, we use the ATT to do the pressure measurement. So what you do the same. You turn off the blower door, you don't start it, and then you start the measurement of the ATT. And what the ATT then does, it has a little valve on top of the vessel, and this valve closes the vessel. So in the vessel, we have now the base pressure that was in the house when the blower door was not running. Next to that valve, there is a little differential pressure sensor on the ATT.
Welcome to the Flow Lab, the podcast where we dive deep into the science of building performance and HVAC innovations. Today we bring you another insightful episode aimed to enhance your knowledge and expertise in the field. Joining us are your co-hosts, Ben Walker, co-CEO of RetroTec, and Sam Myers, a renowned building science specialist and RetroTec trainer. Together, they bring a wealth of experience and knowledge to ensure our discussions are both informative and engaging. So, sit back, relax, and get ready to enter the Flow Lab, where we'll explore the world of building performance. Let's get started.
Welcome to the Flow Lab podcast. I'm Ben Walker. This is Sam Myers.
Hey.
And on today's episode, we have Niek-Jan Bink from ACIN, developer and producer of the Flow Finder and a bunch of other different great airflow diagnostic tools coming out of The Hague and the Netherlands. So,
I know most of us here in the States, we only know ACIN because of the Flow Finder, but there's actually a wide variety of other things that they do. So it'll be cool to hear Nick talk about all that.
They've been around for quite some time now, I believe, with the founder now being in his mid-80s, still showing up to the office once in a while and stuff like that. So
yeah,
they've been around for a long time and do a lot of great things there.
Yeah, back in 2019, I had the privilege of going over to the AIVC conference and then heading over to ACIN's headquarters. And Nick gave me a nice tour of what they had going on and what their calibration room is like and some of the R&D that they have going on. So it's pretty fascinating.
Yeah, and you also got to see like the very first Flow Finder too.
Yeah, the Mk2. Yeah, I think we have one there at the shop, don't we?
I think we do, yeah. It's like came out in the 80s. Is that what
so longer than most people realize.
Yeah, definitely. Kind of stem from just properly commissioning airflow systems in the Netherlands, really, right?
Yeah, ventilation systems.
Yeah. But, Nick is a super smart guy. He's a lot of fun to hang out with. I ever get a chance to meet him at a trade show or anything like that. He's
have a glass of wine with him.
Yeah, drink a lot of. Bring him a bottle of wine, then he'll fill his guts. Tell you everything he knows. Now he's super, a lot of charisma, a lot of fun to hang out with, and we always get a chance when we connect to try and get out and play a competitive round of golf together or whatever. So that's always fun.
Yeah, and every now and then he'll head over to the States and go to HVAC school or maybe sometimes building science summer camp over at Joe Stebrick's. So
yeah, definitely.
He makes it over here every now and then.
And I think he will be here for the HVAC school in February.
Yeah, so. I hope so. We have a presentation together.
Yeah, right. Okay. Well, me too then. But awesome. Well, I hope you guys enjoyed the conversation with Nick, and we'll crank it up here.
Yeah, enjoy.
How's everything at ACIN these days?
At ACIN, I'm not there that often anymore. These days. No, I'm kidding. I'm sitting here in my room on the first floor of my house, which is still being rebuilt.
Oh, wow.
Okay. So you work from home?
Well, today I had to work home, and but at ACIN, things are fine.
Yeah. And then when did you start there?
Me?
Yeah.
2001.
Oh, 2001, yeah. How'd you find out about him?
Before I was a climate researcher, working at the university as a assistant professor. And we did many field experiments. Like we went to Greenland to stay on the ice glacier for 6 weeks and doing all sort of temperature, humidity profile measurements and all sort of. We also had a radar to measure temperature profiles. And that equipment I bought at a company called Wittig & Visser.
Oh, wow, okay.
And that's the sister company from ACIN. ACIN and Wittig & Visser is the same company.
Okay.
But at some point at the universities, the budgets were running low for field experiments. And I was teaching mathematics to first-year students already for more than 10 years. And when students come in, they are 18.
Yeah.
I turned a year older every year. So at some point I was getting a bit bored with this.
Kind of researcher theme, yeah.
Yeah. And I was assistant professor, and I wasn't very good at writing scientific publications and all that kind of stuff. I preferred to organize field experiments, so I wouldn't become a professor.
Yeah, if only you had ChatGPT back then.
No, they didn't. No. But at that time, there weren't enough archive, I think, to write proper articles. So ChatGPT wouldn't have helped me, probably. I'm afraid. No, but so I came to talk with Bill Struik, who you may know.
I believe so.
That's the father from Hendrik. You met Hendrik at our company.
Yeah, the very first visit, yeah.
Yeah. And Bill is still there. He's now 83, but then he was like, how long is it ago? 24 years. So he was still in his 50s. And we went together to Berlin to visit a site where there was some equipment I was about to buy. And we started talking about, I was talking to him about his company and asking, and they were looking for someone. So I took the step to become a sales engineer, from assistant professor to sales engineer, with the prospect to become a co-owner or step up. That took about 8 years. In 2008, I became a partner in the company.
Oh, nice.
Right.
Yeah, I know back here in the States, I mean, most people only know of ACIN because of the Flow Finder, at least in our industry. But you guys make a lot of other different stuff.
Yeah, we sure do.
Yeah, what are some of the kind of different directions you guys go in?
Well, the biggest direction, or the most important product we make, actually, which is one of our bigger products, is a system of pressure valves that are being used in naval vessels. They are at the end of the climate system of a naval vessel. What they do there is they keep an overpressure in the whole ship, at least where the people are living and where the people are working. The whole ship is being held at a overpressure of about, depends a little bit on the ship, but mostly at 300 Pascal.
Oh, wow. Huh.
So which is quite a lot, huh?
Yeah.
You know that you won't be able to open a door at 300 Pascal. That's impossible.
Yeah.
So, and this 300 Pascal is the air inside that gas-safe area is being filtered with huge HEPA filtering systems in such a way that they can sail through a nuclear cloud or any poisonous cloud which is outside. They can sail through it and stay alive in that area. So they will survive if they get in dangerous areas. And we deliver those kind of systems to the companies that build the big climate systems in those ships. So you could think of Johnson Control or that kind of companies.
Well, so a big safety aspect for that.
So that's an important product of ACIN. And next to these products like Flow Finder and all the stuff we make ourselves and what you have seen like Ultragraphics and VentiFlow, we are also distributor for a number of brands, European brands, and also from the US. We have like ultrasonic anemometers. Those are being used in meteorology to measure turbulence. Another side of the business is plant research. We also have equipment from actually being built in the US in Amesbury, Massachusetts, by a company called PP Systems. They make systems to measure photosynthesis.
Oh, wow.
Which is really something different from the Flow Finder.
Yeah.
The general motto of the company is that we think that we know something about the physics of air.
Yeah.
That's our main theme around which we are building all sort of and selling all sort of equipment.
Yeah, so like the Flow Finder, they had already invented it before you started at ACIN then.
Oh yeah, way before. In fact, the idea of zero pressure compensation is from the early 1900s. There weren't like really instruments for it, but it was already sort of invented and thought of by the Germans. And there was very old literature on it. But the idea was used in practice in the early 80s in the Netherlands when TNO, which is our national research institute for all kind of research fields, and one of them was to improve ventilation in houses at that time. So in the early 80s, in the previous century, the heat recovery units started were used in the Netherlands. They use it in a neighborhood somewhere. They build a whole new neighborhood with heat recovery units, and everybody gets sick.
Oh, no.
Because they installed the HRU and they didn't do any commissioning to it. They just installed it. And at some point, they found out that the systems were causing a huge underpressure in all the houses. And radon was being sucked in like crazy.
Oh, no.
From the foundations. And so people got sick and headaches and bad air and everything else. And of course, the factory from the HRUs were blamed, but
it's like the installation.
Could blame them because they didn't give enough education to use the systems.
Yeah, how to balance
nobody had an idea to how to commission such a system, and they tried it with just plain simple anemometers, and they did something, and then TNO came up with the ideas. Clever guy at TNO came up with the idea to build a flow finder. He formed us all this year, and we built the first flow finder. Designed the first flow finder in the 80s. So that is almost more than 20 years before I came to ACIN. And you had it in your hands, I think, Sam.
Yeah, the original one when I was there. Yeah.
When we were in the wind tunnel room, I showed you one. So it's like an aluminium box. Can you see it this big?
Yep.
It's high.
I'll try to send it up here. I have it here right now, so I'll try to take a picture and put it up during this part of the.
I left a copy of it. I think.
Yeah.
Or a sample. Yeah. So and that is existing of that is how do you say it? Assembled of like from 250 parts.
Yeah, from scratch.
Everything was made by hand, and everything was. So when I started working at ACIN, we were still building that flow finder, and we sold about 10 a year. And people were, at that time, HRUs and measuring ventilation became more popular all the time. And we started to make a system to build 25 a year, and people had to wait for it for months. So I could say on the phone, I could say to them, if they wanted the flow finder, I said, well, sit down. I'm going to give you a scare, but I'm also going to give you, I'm going to put your mind at ease because you have to pay $6,000 for it, which is expensive, but you can save for half a year because the delivery time is half a year.
No.
So around that time we started, I was only, in sales and I couldn't decide what to develop. But when I became partner in 2008, the first thing I did was to make a program to develop a digital flow finder, as I call it.
Okay.
It's the flow finder we have now.
Which is the Mark II?
The Mark II, yes. Yeah. Because the other one was the Mark I.
Yeah.
And I went to our designer and I said, well, I want something like this as a hood and a motor in it and a ventilator, and it should do the same job as the flow finder that we have now, but in a different way. Yeah. Because the old flow finder had a motor and a ventilator which ran at a constant speed, very high speed, and you made a hole above it bigger and smaller. So you sort of brought in resistance to lower the flow and less resistance to get a higher flow. And there was a little pressure vane in it, and you had to turn the knob and control the hole in such a way that the vane was in the middle. And the vane was, so it had pressure from the top and pressure from the bottom. And when the vane is in the middle, the pressure is in balance, so you have zero pressure.
Yeah.
Wow. The system. And the vane was a little vane with a little axis, and it was mounted between two robins. How you say it? Diamonds.
Yeah, ribbons, or yeah. And then how long did it take you guys to develop the Mark II from the beginning?
Well, that was about 3 years.
3 years, and long.
Yeah.
Not bad.
And of course, we already had the ideas, but I didn't get too much funding at that time. But at some point, we really speeded up the whole development, and we did it. I think we did it in about 2 years. So 2011, we were on the first, we had a sort of a 3D print of it at an exhibition. And you know, the 3D print at that time was like really vulnerable. It was
it's like fragile.
Yeah. And everybody we used the same knobs on the Mark II that were on the old flow finder. And this big guy came up in our booth and he picked up the flow finder and he says, "Does it work the same?" And he turned them up.
Oh, no.
He said,
It's time to get out there and super glue like this.
I had I needed some glue to repair it for it. because it wasn't a working unit. It was just a model that we showed on how it would become.
Yeah, it's interesting to hear. In the 80s, at least the Netherlands was thinking about ventilation. Here in the States, in the 80s, we were starting to make houses tighter, but we didn't realize that we were getting rid of the natural ventilation that air leakage gave us. And so then tight buildings started to get a bad reputation because they were starting to rot out.
Exactly.
So, yeah.
It's a bit similar. It's not really similar because they thought of the HRU and they make the house tight, but they forgot that they should. And that really that really stopped the development of the HRUs for a long time because nobody wanted it anymore. It immediately had a bad name.
Yep, that's how tight buildings are with us. We're still fighting against it. We're still having contractors say a house needs to breathe. And we're like, no, they need to ventilate.
Well, I have it in a small way at the moment because I moved from my large house to this smaller house. And I decided to make it airtight and to install a HRU. And I told Sis at some point when she came in the house, I said, well, you can't open the windows in the front anymore because of the ventilation. And she sort of looked at me. She almost kicked me out of the house. And
where am I going to get all the fresh air from now then?
It was really hard to explain. I had to dig up all sort of literature and to show her.
Yeah, that's funny.
I guess there's something to being able to see that window open, that immediate satisfaction to make you feel better about it.
Yeah, and the problem is that we are now living here for about 5 months and we are living on the first floor because the ground floor is still being done. And I also still have to install the HRU. I'm doing it more or less myself. So, and you can't open the windows. So
I know about all about those projects that you have to do yourself. They always take the longest.
Yeah.
So it is for me anyway.
Myself. I have some help, but
I saw your social media post about it. It looked like you had all the materials there and everything.
Yeah, we're getting there. I will make I'm not going to post every day the progress, but at some point I will post a story of it. And I asked the question, and January said something like, "Can you say it in American? Because I don't know." I wonder what was so difficult about it. I guess he was asking a simple question.
He wasn't able to wrap his head around what you were up to there.
No, probably he didn't realize I don't have air conditioning.
Oh yeah.
And he lives in Miami, Florida, so that's all he knows is air conditioning.
Yeah, no, that's really a really different cook.
Very different climate.
Yeah. Well, I'll discuss it with him when I'm in Florida.
Oh, I'm sure. You'll have to bring some videos.
Yeah, I will. I had some nice.
Sorry? I was going to say, now you guys have the Flow Finder, but it's like the upgraded Mark II Plus now, right? With the display and Wi-Fi and a bunch of other cool features and stuff. Do you guys plan on doing like a mobile app eventually with it that communicates with it to keep the data and stuff? Or
nice. The idea is to do that.
Good, because that's what I've been telling people.
Don't announce it too quickly because there's still a lot. At this moment, we are giving some extra. We are investing most of the time in getting the ultra graphics ready.
Yeah. Which are you prepared today can you do a demo for us? Do you think, or
now?
In a little while?
Yeah, in some weeks, you mean?
Oh, in some weeks. Yeah. Okay. Sure. Yeah.
Not tonight because I'm at home. I don't have a system here. So.
Okay. Sure. Yeah. I was just curious. Yeah.
That little while is relative.
Yeah. It's really right.
My little while may be different than.
And to do I can send after this. I can send a video with a demo of it. Is that okay, or do you want to do it on a live podcast?
Maybe both at some point or something like that. But we did just see each other at AIVC conference in Dublin, and there was a significant amount of interest in it. It is a cool, like the hardware that you have now seems like it's much more dependable and like a little bit easier to use than the previous version and stuff as well, whatever. So it seemed like
it's at least much more robust because it uses Wi-Fi instead of Bluetooth. And we've added some functions that you can, you can use a headphone to listen to the leakage, not only to make a picture of it.
Yeah.
But also listen to it, which makes it handy to trace down leakages.
And just has like an ultrasonic transponder and then has the receiver on the other side. You can take an image and then go over it with the camera and see where the leakage is coming from.
Yeah, that's the idea.
Yeah, that's super interesting. Yeah.
Yeah, that can come in handy on site. If you're just looking at specific assemblies and the house is still under construction, you don't have to kick workers out.
That's when you really use it.
Yeah.
That's when you really can use it.
Yeah.
That's
especially looking at window
it's
details and things like that.
People always ask, can I give the N50 or something like that? I said, no, an N50 you can measure with a blower door.
Yeah.
Like you can put a nail in wood with a hammer and a screw with a screwdriver. You can measure with ultrographics. You can measure leakages while you are constructing and in construction. And you can measure the real air tightness with a blower door. So it's different tools that add on to each other.
And it's like qualitative too, right? So it's just kind of showing the difference between the worst leak that I found and the tightest area and stuff. Yeah, just based on the ultrasonic signal.
Yeah, and between now and let's say a few years' time, maybe we can come up with that. You've heard it at the AIVC conference, maybe that the Germans are working with a system with lots of different different frequencies. And if you use different frequencies and you get with one frequency you get a hole and with the other you don't get a hole or you don't see a hole, then you can say something about the size of the hole. But I think that's still far away.
Yeah, and then they're also messing around with different hole shapes and stuff like that too, right? Like the types of holes that you might see or the structure of them. Yeah. Yeah,
but I doubt like if you want to make something airtight, who cares what the size or what the shape of the hole is? Just close.
Yeah.
Yeah. We don't care what the shape is. We just don't want it there to begin with. So.
Yes, exactly.
Yeah.
You want to get rid of them.
Yeah, I could see that coming in handy for commercial construction too, because usually they have to build a little separate mock-up chamber of a window detail or a door detail that's enclosed, and then using it that way to see, where on that detail they might be getting some things wrong.
Yeah, we have a manufacturer of prefab houses here in the Netherlands already that is using the ultrographics for that purpose.
Oh, nice.
If you have a wall with a window in it, you can stand on one side of the wall and on the other side of the wall with the source and with the detector. And you can check that particular window without having to do anything else or making it airtight or whatever, or make some kind of construction.
When do you plan on having the ultrographics available for the general public to purchase?
Well, general public, I would say it needs to be somebody skilled. But you mean when it's available for everybody? I hope to have it available in, let's say, late spring next year.
Okay.
Early summer.
Yeah, nice. Keep my eyes peeled for it.
Yeah, I will. You have to see, it's a bit like your beautiful air tracer that just came out. It suddenly was there.
Yeah.
So will the ultrographics also be there at some point? Suddenly it will be there.
Yeah, nice.
Nice.
Yeah, we're getting better at not revealing the R&D projects that we're working on too early.
Yeah.
Commit to timelines that are challenging to meet. We're doing a little bit better job there now.
Yeah, that was great. That was great to see. ACIN is really happy to start selling it as well.
Oh, nice.
We have a website with smoke products, just with all sort of smoke pens and smoke bombs and whatever.
Yeah.
To test systems, but the air tracer is a really nice to add it to that.
Yeah, they've been selling really well, and it's kind of a cool product and a good price point and everything. So
yeah,
some good features in there and stuff.
Sure.
I'll have to get you some.
Well, I've asked a quotation from Rob.
Okay. Nice. Yeah, okay.
Expensive.
From him there.
Can I get it direct?
Maybe. We'll edit this part out, and then we'll.
Yeah, you have to. I don't know what is this. Where is this podcast being broadcasted? Actually,
right now it's just being recorded, and then we do have the ability, it'll be segmented up and everything, so we can chat like this and edit this part out and everything. It's all
yeah.
We just
pretty much anywhere you get podcasts, so Spotify, Apple Music,
Spotify, Apple, hit all the big players.
Are there already podcasts published?
There'll be the first one comes out this month before the end of the month.
We haven't announced it yet.
That's the one with Aeroshoe.
We haven't decided yet because it could be the one with Colin or Harold.
Colin, that's a nice start.
Yeah. So that kind of makes sense since the founder of RetroTec, the first podcast.
Yeah, of course.
But,
of course. Yeah.
So we have.
I was just at at the Build Show Live. I don't know if you've heard of the Build Show. I saw it. Yeah, so they had their first conference in Austin, Texas, and whenever you have the Ultragraphics ready, if you want to send a demo unit over, I've got some really nerdy builders that would really like to try it out and give it some feedback. So yeah, let us know when you get to that point.
Well, when I'm that far, as you know, I like to travel to the US, so I'll bring it myself.
Right on.
I haven't been in Texas yet, so.
Yeah, Dallas this time of year, next year, I guess, right?
Yeah.
Build show.
Yeah, we were back in Texas in August, and it was 109 Fahrenheit and high humidity. So,
oh my
God. I'm glad it's going to be a little bit later in the year.
109 Fahrenheit. Wow.
Yeah.
That's crazy.
Yeah, it was not pleasant during the middle of the day.
Yeah, but one of my biggest fans of the Flow Finder, by the way, was Colin. Eh?
Oh yeah, initially, right? Like when did you get?
2013.
Okay, that's when you first started talking to him. Man,
I still have the email conversation with him, which was endlessly very interesting, and a lot of extremely clever questions and remarks. And the fun thing about Colin was that he has a bit the same that Bill Sturicas has at ACIN. He's both commercially strong, but also technically. So he had an idea of, maybe his predictions were a bit out of line. He was a bit...
it's a little optimistic.
Yeah, a little bit optimistic, a bit Elon Musk-like. He thought there was a market for several thousands of flow finders a year, I think, at some point. He thought that would be easy. It was such a great product. His view that I said, well, Colin, let's see what happens.
Yeah. We're close.
Yeah, we're extremely happy with the numbers that we are doing in the US. So, but there was the Passive House show, I think it was in 2013 in Vancouver.
Yeah. Okay,
yeah, where we presented the Flow Finder.
Yeah, nice.
I got into RetroTec in Vancouver to go to the show.
Yeah.
And as always, Colin was very busy, so he gave me a room and he said, well, here you can prepare for the show and see you in a day or two. But I had fun and I prepared it and after that we had he took me on a cycling tour through Vancouver.
Oh yeah, like in Stanley Park and stuff. And
yeah.
Greville Island.
Very nice tour.
Yeah.
And we had dinner at this boat, which was a big bowl of popcorn.
Sounds about right.
Yeah. You recognize that?
Yeah. Then the spray on butter.
The spray on butter, yeah.
It's really good
for later, when I visited the company in Everset, we also went with you and Colin to that little place, Holland. What's it called?
Yeah, exactly. Like Little Holland, we call it, but
Holland.
Linden, yeah.
Where I stayed in the hotel.
Anybody that comes visits us from the Netherlands, we bring there just to show off.
And I remember that we were walking through the street up and down like 10 times before he decided which restaurant he wanted to go.
Yeah, it keeps things interesting, It keeps exciting.
Yeah. You never know what's going to happen next.
Yeah.
No, but that was great. He did all the work for us to bring it to the market at that time together with Mario.
Oh, yeah, exactly. Yeah, Mario, yeah.
When did you start at RetroTec, Sam?
I started in 2018. So
okay, I see. Also
going on 7 years. Yeah,
well, time flies. Huh?
I know.
Time flies when you're having fun.
Yeah, exactly.
Yeah, and we do.
So, and how about the other thing that we brought on the market, and it's an interesting discussion point. I'm starting to do it now, starting to get a little bit of success with it in the Netherlands, is the ATT. And how do you see that product?
I think it's really super interesting. Like, one thing in the US, we don't really have like an air handler in order already installed that we could create that pressure differential that you're looking for. So like that part seems a little bit challenging maybe, but certainly interesting device.
I'm bringing it up. I don't know if you want to keep it in or edit it out or whatever, but the thing that I'm feeling is that the blower door people see it as a big competitor to the blower door, and I don't see it that way. I see it as a tool that you use in certain times that you can need it, but in the end, you need a blower door again.
Yeah. You want to just give us a quick rundown on how the ATT works?
Yeah. If you have a blower door, what you need to do is first you have to install the blower door in the front door, and then you bring a tube outside, and you do the reference or the base pressure is your outside pressure. And what the ATT does, it is a little vessel in which you more or less store the base pressure. So you start like you do with the blower door experiment. You prepare the house for the measurement. And what you would do, you would start your measurement and take the base pressure. Right? That's what you first do when you start the blower door experiment.
Yep.
And what you do with the ATT, you need some blower. Let's say that, like you are saying, you don't have the ventilation system at hand to do it.
Yeah.
So let's use for the example, let's use the blower door to do it.
Sure.
And we use the blower door to pressurize the house. We use the ATT to do the pressure measurement. So what you do the same. You turn off the blower door. You don't start it. And then you start the measurement of the ATT. And what the ATT then does, it has a little valve on top of the vessel. And this valve closes the vessel.
Yeah.
So in the vessel, we have now the base pressure that was in the house when the blower door was not running. Next to that valve, there is a little differential pressure sensor on the ATT. Now you start your blower door. What you then get, let's say we pressurize the house, so we do overpressure. Then the differential pressure sensor measures a pressure of, if the blower door is making 10 pascals, the ATT will show you 10 pascals. So it's just measuring the differential pressure that you cause with any device with which you are pressurizing the house.
Yeah.
That's all that it does. So what you need to enter into the app, into the calculation, you need to enter yourself the flow. And so the flow amount you need to enter. Now you have two things. You have the differential pressure and you have the flow. From that, you can calculate the air tightness when you assume a value for the flow exponent.
Yeah.
And normally the slope of your blower door measurement gives you the flow exponent. The ATT assumes a flow exponent.
Yeah.
It uses 0.66.
Okay.
Sure.
Given the pressure, the flow, and the flow exponent, you know the air tightness, and you can calculate it to any pressure you want. 50 Pascal, 10 Pascal in the Netherlands we use, 4 Pascal in France,
Right.
50 Pascal in your... And you can use with all the units you want, the square meters, square inches, you can use all those air tightness indicators.
Yeah,
So that's interesting.
Like less acceptable to wind and things like that, since you're not referencing the outside when you're taking the pressure measurement and things like that.
Yeah, but in fact, you are if there is no blower door running, your difference with the outside will be zero, or maybe minus 1 Pascal or 2 or maybe a half a Pascal. The interesting thing is, if you are measuring an airtight house, you can have a lot of wind outside without having to take that into account for the measurement.
Yeah. That's and anytime anybody says to me that they have the ability to measure air tightness without a blower door, I think, oh no.
I can imagine.
But then it's not always a bad thing either, because then it kind of reinvents the idea. So it's like, it's not always negative or anything. It's just
but the history behind the ATT is that the development of the ATT was subsidized in the Netherlands.
And the research came from like a local university there or something like that.
It again came from TNO.
TNO, okay.
So Wouter Borsboom probably from the AIVC.
Yeah, I did just see him there. Yeah.
Yeah. Well, I did the project with him.
So
and why?
I have one right here.
Yeah, there it is. Yeah.
Arms reach away. It's like,
yeah, you can open the box. But the idea was that in the Netherlands, you only have to test 5% of, if you build an apartment building with 200 apartments, you have to measure 10 of those apartments with a blower door.
Yeah.
And if those 10 are okay, all 200 are okay, which is crazy because you don't know if there are any errors or whatever in the houses.
Yeah, small
so the idea was measure those 10 buildings, measure those 10 apartments with the blower door. Then you also know the flow exponent of those 10 apartments. Yeah. And then you can assume that it is, and suppose those apartments are okay, they are fulfilling the demands that they are asking. Take the ATT into the other houses assuming that you then have a ventilation system that you can turn on and off, and see if you make approximately the pressure that you are expecting.
Yeah.
By turning on and off the ventilation system. And if you don't, go in with a blower door and find the leakages.
Yeah.
And then you can test all 200 buildings. Now, for instance, in Ireland, they are saying you have to test all houses with a blower door. And they are getting crazy of the amount of work that they have to do. It's not feasible.
Yeah.
Yeah.
And that's so.
That's when people tend to just like take shortcuts or not do it at all or things like that.
Yeah.
So,
Yeah.
In fact, the 1 point measurement was always advocated by Max Sherman. He says that doing a multi-point measurement with a blower door is okay, but you can just as well if you want to know the N50. Just take 4 or 5 measurements at 50 Pascal.
Yeah.
Yeah.
Which is also a 1 point measurement.
Just a repeated single point. Yeah. That's what they call it. Yeah.
It's actually in your standard.
Yeah.
Yep.
It's an interesting, like then, so when you do the testing with the ATT tester in Europe, then you take the flow measurement with the Flow Finder of the ventilation system and use that as
the empty flow. Well, actually, we just did a comparison in an apartment building in the north of the Netherlands. And what we did, we just took the word of the installer that his unit was doing about 50 CFM. And we just did a test with not measuring with the Flow Finder or the VentiFlow at all, just see what we got.
Yeah.
And it just showed that the apartment was not airtight because they wanted 0.4 ACH, 10 Pascal, and they were not reaching 0.7. So even if the flow was like half of it, it would not have reached.
Yeah, it didn't pressurize.
That was enough to bring in. That was enough reason to bring in a blower door and to check where the leakages are.
Yeah.
Yeah.
So they could do a quick check, and it was very convenient for the builder to see that it was not right, and then you can come with. Actually, I was there together with somebody doing the blower door measurement with your RetroTec door.
Okay.
So we were working together.
Yeah, nice.
Yeah, I'll go ahead and tell you, for that to work in my house, I'll need to do some more air sealing in the attic because mine's not going to pressurize either. Not without some extra help.
Yeah. All right. Good.
Yeah, that's interesting. It's kind of another perspective of how to measure that.
Yeah, and like you're saying, it's not so easy to have a unit that makes the pressure or whatever. We are building a little case with a ventilator so that at least you can make some pressure yourself.
Okay.
But that, of course, is not intent. I'm not sure if I want to do that too much, because then the system is getting too close to a blower door, and then you have the same amount of carrying to do with a ventilator.
Yeah, when you're trying to save on the setup time and all that stuff. And,
then you don't want to go that way. But at least I can play with it and see what it's...
or maybe you can just include a Model 300 fan with it.
Exactly.
Yeah,
right.
Exactly. Yeah. Actually, that's what people are doing in the Netherlands also. I think in the US also. The guy that I was working with the RetroTec door, he uses a small ventilator to measure airtight houses. So your Model 300.
Oh, sure. Yeah, definitely.
Yeah.
Yeah. Like more passive house standard kind of stuff.
Yeah, and he makes it in he doesn't put up a door, but he uses windows, which he closes off and puts his tester on.
Yeah,
nice.
It's easier to kind of make your own panel that way. If you just
you can make your own panel and
make one out of
window
corrugated plastic or foam board or something like that.
Yeah,
that's
sure.
cool. Yeah, we have people over here that do that for the passive house standard. You know, they're that tight. You don't really need that much fan power, so it works great.
No, but then in the end, they still need to do an official test, if they want to have it certified by Passive House.
Yeah, and they still are able to use that fan to do that. At
they
let's
do
say
it with
test
fan.
at 50
Okay.
pascals. Yeah.
Yeah. Great.
Cool.
Yeah, then you'll be coming to the States then in January for the HVAC school, or February, I guess, maybe?
January, February, the HVAC school, and because the Ashray is so close to it, I might visit that as well. But
okay, nice. Yeah, the week after, I think. Yeah,
it's in the same place.
Yeah,
it was in Orlando, isn't it? Both?
Are they both are in Orlando?
HVAC school will be a little different this year. It's not going to be at Kalos. They're moving it. They're moving it closer to Orlando to be a little bit more convenient with AHRI or with AHR. Yeah.
That's great. Then you and Sam are doing a presentation there.
Well, I talked on
I got to start one and send it to him. But yeah, we'll have one.
Yeah, nice. I'm just looking forward to it.
Yeah.
I thought I combined a few things, so I gave Sam a call on his birthday, and we discussed also the presentation.
Oh, nice.
Yep. He was a little surprised.
Yeah. I looked at my phone and I was like, oh, no way.
Kill two birds with one stone that way.
Yeah.
That's like good.
Yeah, so the idea is to give a presentation together with Sam, and Sam had some ideas, so I leave it to him to if you want me to do something, or if you need some material, then let me know, Sam, and we'll go from there.
Yeah, I've presented on the topic before, so I can go back and put some slides together that I already have and get them to you. Just like I told you last time and still haven't done yet.
Yeah.
So,
great.
Yeah, I'll get them to you soon before it's too late.
Yeah. So maybe it's interesting to mention that I think you've got your first batch of 20 flow finders now with the ISO 17025 accredited certificate with the flow finder.
Yeah.
We finally got our lab accredited.
Oh, nice! Yeah, congratulations! Yeah, that's a process.
Yeah, that's awesome.
Yeah, you know all about it.
Oh yeah.
Yeah. Even if your appointment in Australia is not working, which so no, but it was quite a way to get there. But I think it's quite interesting for the whole flow community here especially in Europe. We did it because in Europe, in Ireland, and in UK and in France, they are making it obliged to have it.
It's like mandated that it has to be accredited. Yeah. Probably UCAS accreditation. Yeah. But did you discover anything in like improvements in the lab and stuff like that came out of the initial assessment or anything, or you guys were already pretty much doing everything that you needed to be doing?
On the technical side, we hardly had to improve anything.
Yeah.
On the documentation and administration and side, we had to do quite a lot of things. This whole stuff around independency and
non-partiality and all that stuff.
Non-partiality, or whatever it's called in English, and the whole administration around allowing people to work in the lab. You have to have a whole logbook and about how to train them, and
exactly.
That kind of stuff was a lot of work. But and what also was not really difficult, but interesting, was the uncertainty budget for the flow finder, and the uncertainty budget for the setup, the calibration setup. Because I came up with the specifications for the flow finder when we developed it just by experience, just by having done thousands of measurements on the tunnel. Yeah. I sort of saw that and deducted from the measurements like that it's about 3%. And about
your auditor.
No. We had to substantiate it a little bit more now. And we got very close. I only think that we may have to, we keep the same in the commercial folders, and it's not wrong. But if you look at it, the expanded uncertainty might be at the lower flows a little bit higher than this 3 cubic meters per hour. It might actually be 1 liter per second, which is 3.6 cubic meter per hour. And what is it? 2 CFM? 1 point something CFM. But it really came close.
Yeah, well, that's excellent.
That's nice.
Well, that's good enough. We're not happy with it. The idea is to, when we are now, that's the next step of investment, is to improve the experimental setup. We know where the uncertainty comes from. We have a big radial, radial ventilator, or is it actually a radial ventilator? And it's not extremely stable. So you have small fluctuations of the flow in the tunnel, and we can improve on that, I think, a lot. Which would take down the uncertainty quite a bit. And
you have like some turbulent flow in the system that you have to try to smooth out and whatnot.
Yeah, and maybe we may have to use for the lower flows. We're now using orifices.
Yeah.
And at the lowest flow, we have to measure. Actually, Sam also saw that we're measuring on this BETS micromanometer. We are measuring 0.3 Pascal.
Oh wow, yeah.
It's only an experienced eye can do the readings.
Yeah.
And maybe we have to increase that a little bit by using maybe laminar flow elements or something like that. So just really change the setup to. Once you can accredit yourself for an accuracy of plus or minus 10 CFM. If you have that on your scope, you can make a certificate, no problem. Yeah. But nobody is very. It doesn't help. Let's say that.
Yeah.
We want to improve on the lower volume flows. We want to improve a little bit.
Yeah.
Not so interesting for the US market because most of the flows start at 10 CFM or more at least.
Yeah. 10 CFM is pretty low. That's kind of like a small bathroom with all interior walls.
Yeah, exactly. No, the biggest improvement for you is, I think, the stability of the flow finder at the high flows down.
Yeah,
that's what.
At which it's is measuring.
Yeah, taking more readings per second to get to reduce that fluctuation to get there faster. That's nice.
And maybe it's good to repeat that in the podcast. We are working on a further improvement of one of the hardware components of the Flow Finder, which is the motor controller. And to get that new motor controller in your Flow Finder, it needs to come back to you. You can probably do it yourself. But we are giving those motor controllers for free when we have it. So it's included in the price of the update.
Okay.
The Mk2 Plus, and it's also included in the price of everybody that bought an Mk2 Plus.
Yeah, nice.
So we give you the hardware to do, and well, we can certainly learn your guys to replace it and to update it, like you are doing now with the older flow finders.
Yeah, Sam. What about this? Like a brief statement, like about in the U.S. what people use the flow finder for?
Yeah, I mean, mainly it's used to balance HVAC systems, right? Because in the U.S. we have, ducted heat pumps and air conditioners. So we'd have to do our heating and cooling load and whatever software we do that in, and that also gives us how much flow that we need per room. And so, in the commercial world, all of that's done by a separate contractor, a test and balance contractor. And in the residential world, that usually just gets overlooked and doesn't get done. But now the really good and focused HVAC contractors that understand the importance of this stuff are realizing that the Flow Finder is really the best tool for that, because it's the only flow hood on the market that is a powered flow hood or an active flow hood that has its own calibrated fan and micromanometer built in. So it's actually able to get that small amount of uncertainty so that they can be more confident that the actual house is matching the design from the heating and cooling load, or the manual J and the duct design. But we also have some of the more high-end home builders and some of the other HVAC contractors, energy auditors, and HERS raters that are using it to measure whole house ventilation. So if we have HRVs or ERVs, or if we have a air cycler that has a duct going from the return side to the outside, measuring that. We have an ASHRAE standard that provides a calculation of what that should be And so they're able to measure that from the outside or the inside, wherever they can get to it, to make sure that that flow is actually providing the right amount of ventilation. So those are really the main uses that we're seeing it for. And then you've got guys like Jenry Garcia that are using it to measure how much airflow is coming through a can light whenever they're running their blower door at 50 pascals. So just to be able to show the homeowner, it's like, here's 1,000 CFM 50, boom, okay, here's 10 of them. And you have how many of those can lights? So it's a good visual for contractors like that too.
Some great use cases,
Yeah, he had some great other experiments with the Flow Finder, which he sent me all sort of questions,
at
and I thought, what
grills,
is he doing?
Whenever that transfer grill, trying to see how much air is going through it in real time when you shut a bedroom door. So, yeah, he's probably the one that's really put it through the ringer the most here in the States anyway. So he's a good one to get feedback from.
Yeah, he gave a lot of feedback, and I'm not getting much feedback anymore, so I think he's happy because
no news is good news.
In his case, sometimes it is.
He doesn't keep it to himself, so
no,
and that's a good thing. That's how we learn. So
we
learn from customers like that. So we're glad they're out there.
And then there's like the Mark II Plus. It has like a greater flow capacity now with the new motor controller and all that stuff in there, like similar
Actually,
to
that's what we just saw. We just found out, or we just realized that, well, first of all, one comment, which is important for the US market, we had lots of comments on the battery and problems with the battery. Maybe it wasn't treated well or whatever.
Yeah.
But the thing in the US is that you are measuring higher flow, so the battery had to work way harder than it normally does in a European system.
Yeah.
But we found with the Mk2 Plus, like your comment the first time that you heard the Mk2 Plus, you said to me, hey, it hasn't got a new motor.
Yeah.
It hasn't got a new motor, but at the high flows, it's not doing like hee, but it's doing zzz, because it's controlling way better. And for that, the power consumption of the battery is way lower.
Yeah, so way more efficient than
And I think that first of all, I don't think we need the lithium-ion battery now because of the much more improved
efficiency and everything. Yeah,
efficiency, and that will even become better when the new motor controller is there.
Okay.
Then we have some more parameters that we can use to do the control. And the second thing is, what I realized is that actually we can indeed extend the measuring range. And it's not a huge, it is in numbers. It's interesting because I think we can raise it about 25%.
Oh wow,
that's substantial.
And that's substantial because I think you now have 550 CFM as the highest.
I think so. Yeah, I think that's where the top end.
So that could go to 700 CFM, maybe.
Wow,
we are looking at it.
And that's still compensated flows, or
it's all compensated. Yeah. That's the fun thing. We did a measurement at what is it in CFMs, 650 CFM, and it did just compensate like that.
Okay, yeah, wow, nice.
Yeah, and I don't want to get into this calculated compensation stuff anymore.
Yeah, right.
We must admit that was a little bit tricky.
Too tricky.
Yeah, it had to do with the fact that when we made the design in 2000, or not the design itself, but I made a spec sheet, and I made all the specs, and one of the specs was that it needed to have. There was another powered flow hood coming on the market, and I wanted to have at least a 2 times higher range. So from that day on, we worked on that higher range, and we came up with this calculated compensation. It worked, but it wasn't perfect.
Yeah.
Yeah.
Then I've had recently people asking me about using it to measure the linear diffusers and stuff like that. There's no correction factor that you have to use when you're changing between the hoods and stuff, like for the 24x24 or the diffuser hood or anything like that, or
that we can do that. We can bring in in fact, what I've been thinking is that we should at least the flow finders that we export to the US should work for the hood you want. You are using the most.
Yeah.
And we can also. I'm a little bit reluctant to put in we could put a function in the software where you have to choose which hood you are using.
Yeah.
Yeah, but that'd be nice.
Might not be.
Well, is that so? If you forget it and then you come home and you think, oh shit, I didn't have the correct hood on. Yeah, maybe you can then do a calculation to correct that, but we can do it.
Yeah.
Yeah.
That's kind of like what we do with blower door testing. Like if you go out there and if you get back to the office and you realize you tested the house with a blower door with the wrong range, you can go back and fix it easily with a simulator. So
yeah. Oh, actually, I got a comment from some of my friend who was using that blower door, and he was not happy with the fact that he had to change from 2 to 4 to 6 to 8 rings instead 2, 3, 4, 5, 6, 7, 8.
Oh yeah, like it's like a skipping numbers, not sequential.
Yeah, you have to skip. I don't know. I didn't work with it, but that is what he was saying. Do you understand that, Sam? Or is he doing
I'm trying to wrap my head
wrong?
around. So what's he doing?
Well, yeah. If you have a certain flow range and you're not getting to the pressure that you want,
you open up the fan then.
Right.
You have to open up the fan, but you can't take out one ring. You have to take out 2.
Oh, okay, yeah. Yeah, there's some overlap there and so it doesn't. I mean, from a calibration standpoint, it doesn't make a lot of sense because there's overlap. So you can get there with any of the other ones, so it doesn't make sense to add another one in there where one of the other 2 ranges will do it. So
I'll tell him. So when you take out one ring, the overlap is way too big. That's what you're saying.
Yeah, I mean, there's a little bit of overlap between ranges anyway, and usually you want to go with the smallest. You'll get a better reading if the blades are spinning faster. But yeah, I mean,
and your certificate is probably only made for
those particular configurations. Yeah.
Otherwise, you have to double the time of calibration.
That's correct.
Yeah.
Yeah. Okay.
And that configuration has to match, whatever the picture is on the gauge, because that's how it was calibrated at the factory. So
yeah. And then the number just matches the openings that are open. So
yeah,
I can see the point though.
Yeah, I see the point.
Yeah.
Yeah, it's funny if you see how clever people or how fast people are when they have experience with the blower door. It's incredible.
Yeah.
Oh, really?
It's good fun to see see them build it up, and I can imagine if you do it the first time, it's a lot of work, but they are so fast with it.
Yeah. It's like riding a bike, once you get those training wheels off and go the first time, figure out the process.
And it's electric, and
But to get shortly back to your very good story on your very good explanation of what they do in the US with the Flow Finder, it's so funny to see all the different ways and they use it. It's way more advanced than they do it here in Europe, because here they only use it for commissioning.
Yeah,
you haven't seen all those other
possible applications and whatnot. Yeah.
No.
I think that's one reason why it's getting so popular too, because you can use it to measure different things. I mean, you can use it to measure some of those builder grade kitchen exhaust fan hoods too, because usually they're not going to be more than 200 CFM. So if you can fashion your own hood to kind of go down from that hood down to the size of the Flow Finder, then you can pressure match it. And then being able to do that, plus bath fans, plus balancing the house, plus the whole house ventilation, all with one tool, it makes it worthwhile.
And they also, I had some discussion with people, or I had some questions, and I looked at some numbers from people that do in sort of duct testing with it by measuring the total flow and then measuring all the grills, and then they say the difference is the leakage.
Yeah, I've seen that.
Scared about that, but
yeah,
it's interesting.
Yeah,
it's clever.
Yeah,
Sam's not promoting it, though. You can tell,
yeah, it's not as good as duct testing and sealing everything off.
No, that's in fact what I'm saying.
But it can give you an idea of what it could be. I mean, it can tell you if duct leakage is severe enough where it can cause an issue.
Yeah, Well, the same here. If you find that difference, maybe you were not even looking for it, but you find it. Then you say, hey, maybe it's a good idea to do some duct testing.
Yeah, exactly.
Because how
point you in
much
the right
duct testing
direction.
is there being done in domestic houses?
How much duct testing?
Yeah.
Quite a bit. It's required by code in a lot of states now.
In domestic?
Mm-hmm.
In Europe, it's not at all. They
Yeah,
don't
well,
do
we
it
just
at
we have.
all.
I mean, that's pretty much how we deliver conditioned air in pretty much every house. I mean, we have so much ductwork here.
Yeah.
And especially here, like where I live in the southeastern part, we like to put our duct systems in unconditioned vented attics that get up to 140 degrees Fahrenheit in the summer. Or we like to put them in unconditioned vented crawl spaces, which can be very damp and moldy in the summer. And so when you have return leakage, you pull in nasty stuff into your house. So why we're still doing that, I don't know. But houses are still being built like that today. I mean, duct leakage can really wreak havoc on a house when you have those kinds of scenarios. So if I look lots of contractors are doing it too, just to troubleshoot. You know, if they notice that that's where the system is located and they're having allergies, bad indoor air quality, high humidity, then usually looking at the condition of the duct system is one of the first places they look.
Yeah, the thing is that you really have ducts. We don't have ducts in our houses.
Yeah,
we have tubes, and they are this diameter, maybe this, but this is the biggest kind of ducts we have.
Yeah, we have 14-inch returns and
I saw it like that.
Everything big. Yeah,
maybe now I understand why then Gendry didn't understand my questions probably.
Yeah, right.
The European systems are so different from what you are building. Yeah.
I think he was just poking fun at you a little bit is all. Like the
Yeah,
absolutely.
That crowd likes to do that for sure.
Yeah, exactly. Yeah.
Okay, guys.
Be careful what you post on there.
Yeah.
Yeah. Well, was nothing wrong with the post.
And that can be your response.
I'm going to throw that question into ChatGPT, and I will ask it to
clarify. Yeah, we'll have to. And after you do that, then maybe we'll have you and Gendry on the podcast, and then we can talk about.
That would be fun.
That will be a bit like what's the movie called with John Cleese and. It's the clash between a British and the American culture. A Fish Called Wanda.
Oh, yeah.
Classic, yeah.
Oh, man. Maybe we need to get that one on the books.
Where Ken is eating the goldfish.
Yeah, right, exactly. As we kind of start to wrap up, Nick, then one question I like to ask is if you if you could go back and tell yourself some advice or anything like that for the younger Nick Young, what would it be?
Yeah, it's funny that's an interesting question because the younger Niek-Jan sort of just has started at ACIN. We have a new guy and he has a bit
the future Nick Young is there now. I see that.
Yeah, he is there. Well, the advice is look around, be interested. If you want to know, find out. And also, what I learned is, especially at those conference where we've been, HVAC school, AIVC, you always find people that try to listen to people that inspire you. And there are people around that are so brilliant.
Oh yeah,
that you love to listen to them and love to learn from them, and you hope that you can sort of get in contact with them, but at least learn from them. And if you have a culture where you don't only compete but also listen to each other, and then you can do much more for the good purpose, the HVAC improvement, than if you are only fighting who is the best or who is better. But
Yeah.
I'm inspired by guys like Bill Spoon, by Brian Orr, and in the Netherlands we also have a few of those clever guys. If you listen to them and if you think, I'm not stupid, but I don't know as much about all this stuff that these people know, and it's keep your eyes and ears open.
Yeah, be curious. Yeah, exactly.
Yeah,
be curious.
That's great advice.
But there are also brilliant younger guys like Sam T. Myers. He is when he does a podcast or explains things, I love to listen to him.
Oh, yeah.
He has his good days and bad days.
A lot of editing.
Yeah.
Don't
Gotten good at editing.
Don't rely too much on a lot of editing. Don't rely too much on ChatGPT.
Yeah, right. Exactly.
Yeah.
Yeah. Well, it's like, we still have to be human,
Exactly.
It's a nice tool. And I like the idea that we had, Ben, that if we are in sort of discussions, we don't like both. We both are like talking about all sort of... we can have our both ChatGPT characters talk to each other and let them solve
right.
this.
And we just let them do all the hard work, and then we'll just sit back and drink a glass of wine while we work things out.
So stay curious. I
love it.
That's the shortest way I can say it.
Yeah.
That's great advice. Yeah, definitely. Yeah. Well, thanks again for being. Oh yeah, play golf. Yeah, exactly.
Yeah.
No, great.
Yeah. Well, again, Nick, I appreciate you taking the time and everything today.
Yeah.
And,
Yeah, this has been great.
Things, yeah, definitely.
I'm gonna
It's
wrap
always fun
up
to
with
hear
a
how some of
little,
these companies
nightcap.
come
It's
up.
10:12 here, so
Oh yeah, exactly.
thank you guys.
Yeah,
Yes.
thank you. And well, I guess we'll see you here soon at HVAC school. So looking forward to it.
Yeah,
Absolutely, love to see it. Love to see you too again.
definitely.
Okay,
All right,
Cool.
thanks, Nick.
Yeah.
thanks guys.